This will be the third and final video in this series on forces and equilibrium. This is the normal force. Normal force is introduced here, and it's defined as the support force exerted on an object from the surface it sits on when their surfaces touch. So I have a picture of a book sitting on top of a table, and so there is going to be a support force exerted on the book from the table when their surfaces touch. In other words, the table is going to push up against the book. As the book pushes down against the table experiences 50 newtons of weight from the book pushing down. And so the normal force from the table to the book is 50 newtons up. You assume that the book is not passing through the table and that the book is stationary from normal experience. So if that's the case, then the forces have to be in equilibrium, and so you can know that the normal force is 50. Normal force is used in equilibrium questions a lot of times when they're asking you about what the equilibrium numbers would be. Here's an example. 200 newtons is the weight of this table, and I've shown you the table with its four legs, and I'm telling you that the 200 newton table rests evenly on its four legs, and so then I'm asking you, what is the normal force on each leg? So let's start at it this way. What does the normal force on the whole table have to be? From the floor to the table, what does the whole normal force have to be? It has to be 200 newtons, because that's the exact force of the weight of the table. So the floor is going to push up with 200 newtons. Well, it's doing that evenly on four different places, so each foot would have a normal force of 50 newtons up. 50 plus 50 plus 50 plus 50 would give you 200 newtons of normal force pushing up. Let's look at it a little bit different. Example here. This one is out of your PowerPoint from the internet. It's also in your book. A boat weighing 1,500 newtons is suspended by two chains. So you can imagine this in a boathouse, maybe at the river. The tension in one chain is 600 newtons. That's the force that the chain feels from the boat. What is the tension in the other chain? So at this point, I want you to pause the video before you continue and think about how you would figure this out before you start the video back again. All right. So here's the answer. You can draw a little picture, and this is called a free body diagram. And with a free body diagram, you just draw a simple drawing, and then you draw arrows in directions and label them with numbers to represent all the different forces on an object, and it just helps you keep up with all the forces so you don't lose track, because it can get kind of confusing. So the question told us that the boat weighs 1,500 newtons, so that's always downward. We also know that one of the chains has a tension of 600 newtons, and that's going to be up. And so what's the force in the other chain, or the tension in the other chain? That's what we're trying to find out. So you can assume this thing is in equilibrium. It says the boat is suspended. So what do we know? If it's in equilibrium, all the downward force is going to equal all the upward force, because they're on the same line, up and down. So 600 plus something is going to equal 1,500. And so you can probably do that in your head, but if not, you just set it up like this and use your algebra skills. We don't worship the x, so we have a question mark there. It's just a placeholder. 1,500 equals 600 plus question mark. Do your algebra, and you wind up with 900 newtons. Up is the direction and amount of the force on the second chain. That's all I've got for you. Hope this helps.